participation from all the states in the country, and even some of them are from our neighboring countries also.
So then I will stick to English. There are a few sentences here and there in Hindi so that some will understand it more in a better way. So let me again welcome all the webinar participants, and we'll straight away move to this topic of overview of satellite communication and navigation technology. So instead of sticking to the basics and fundamentals and boring you, I thought that I will try to intersperse my talk actual real-time examples of India's space program. Some of these yesterday you must have heard from my other esteemed colleague also, but these will be more specific to satellite communication and satellite navigation. Some of the concepts as well as how it has evolved into the actual program of ISRO and India, and because that will give you a better insight into the activities which we do related to space communication as well as navigation, which we have embarked on since recently. So we'll move to my presentation. Just I am sharing my presentation. Are you able to see the screen?
No, sir. Yeah, now it's okay, sir.
Yeah. Overview of satellite communication and navigation technologies. I hope it is visible to everybody. उपग्रह संचार एवं नौचालन प्रौद्योगिकियों का अवलोकन overview. So that we'll try to see some of these technologies and how they have been applied. On the screen you are seeing this picture. You are seeing these birds, Gagan, IRNSS, INSS satellite pictures are there, GSAT satellite pictures are there, Gaganyaan picture is there, some of the chips or ICs which you see in your radio or TV, something similar is seen on your screen, which is called Navic chips, and there is a logo of our Navic. So Navic is similar to something equivalent to GPS. We call it our Desi GPS. I'll come to all those details. So this is in a nutshell, I'm trying to cover all these technologies. So starting with the concept, then followed by how we are making these satellites in India, in ISRO, so that these satellites will go into the space at different orbits, and then they will serve the purpose of communication and navigation. So that is the idea of this talk. And then navigation is a new field, and some of these technology, how we apply in our flagship Gaganyaan program, which we are going to start. So already we have started the developments, but we are going to launch probably next year, early next year or by this year end. So our first flight, which will be an unmanned flight. So you would have heard about it yesterday also. But I address it more on the context of how we are going to utilize this satellite communication and navigation in this Gaganyaan also. So that will ignite your interest also in this mission. So I'll cover this. I will call it NavCom technologies and applications. It is navigation and communication, because many of the applications utilizes both the technologies. So welcome to this fascinating world of space, and especially communication and navigation. At the bottom we are seeing our headquarters picture as well as some of the place where I work, that Space Application Center, Ahmedabad. Some of the campuses of that, we have 3 campuses. I'll come to that also. All of you know ISRO Space Vision, you would have known yesterday also. These are our pioneers, Dr. Vikram Sarabhai, who started this program from my place, that is Ahmedabad. Here there is a physical research laboratory. So the whole program, the vision started from this place in early 60s. And unfortunately, Dr. Sarabhai died very early. So then the focus shifted to Bangalore, where Professor Satish Dhawan was then director of Indian Institute of Science. So he could not move to Ahmedabad, so he requested our Prime Minister, then Srimati Indira Gandhi ji, that I cannot come to Ahmedabad, so better you bring ISRO to Bangalore. So that way our headquarters got shifted to Bangalore. And all of you know Dr. Abdul Kalam, so he was one of our great leaders in space, and these were the pioneers through which our space program has been nurtured. And at the bottom you are seeing a very rare picture of Dr. Abdul Kalam with Dr. Vikram Sarabhai. This is one of the unique picture where both of them are discussing quite in detail of some of the concepts. And incidentally, last year we completed the Vikram Sarabhai's Space Centenary Program from 12th August 2019 to 12th August 2020. And in fact, incidentally, on 25th September 2020, Dr. Satish Dhawan's Centenary Program was also inaugurated. So this year we are celebrating up to 25th September 2021, the Centenary Program of one of our great pioneers, Dr. Satish Dhawan. This is ISRO, so I will not go much into the detail. It works directly under Prime Minister of India, Honorable Prime Minister, with the Space Commission, which is guiding all the activities of Department of Space. And at the right hand side, you are seeing the very beautiful pictures of various campuses of ISRO spread all across the country. They are worth visiting whenever you get the chance after this pandemic is over. Please do visit some of these centers, and we will facilitate your visit to any of the center, your nearby center. You can get an idea about the work, the infrastructure, the facilities which we have set up. And now there is some changes going to affect in ISRO also. So we'll bring in more involvement of private sector into our activities. That is what is depicted. So we have these 6 major centers, and recently we have started this Human Space Flight Center also in Bangalore. So that is added to our earlier plethora of 6 centers. So this is the 7th center added to our major center. And apart from that, we have various units and small institutes. And IIRS is one of them, which is conducting all these courses. So I thank IIRS team for organizing these courses, and that will give you the benefit of learning about ISRO and its activities. So this is ISRO, and as you can see here, ISRO is almost spread all across the country. Wherever you are located, you will have something or the other nearby at your place. So you need not come all the way to Bangalore or Trivandrum or Ahmedabad for seeing the activities of ISRO. You can as well watch it at a nearby place from your hometown, your place where you are working, and wherever we are not there, say in the deep north or northeast, we are also setting up our new activities there, and we are trying to rope in various incubation centers for space activities. So that is the mandate of Government of India, that we try to bring space to your doorstep. Instead of you people coming to us, we will be coming to you. And some of this point also. So we make launch vehicles, satellites, and then various applications. So the satellite communication and navigation come under the application, because finally, if the benefits of the space technology doesn't reach you people, to the common people, then it is meaningless. So our idea, our aim, our vision, what Dr. Sarabhai envisaged was that we should apply this technology, space technologies, and especially communication and navigation are one of the major activities or technologies which are very useful for doing the activities of a common man. So how we will do that, whether it is disaster management or finding out natural resources, environment related studies, atmosphere related studies, climate studies. Recently we heard a lot about various cyclones. In a quick succession we had 2 cyclones. So how this cyclone progression has happened, and you may be surprised to know that earlier we used to have there also casualties were limited to minimal numbers. So that all is possible due to the application of the space technology. So I will dwell upon that. So disaster management and other activities, the satellite communication and satellite navigation play a major role. This is ISRO. We have almost completed with this pandemic. Some of the activities were affected, but still we have been working in the background. Ahmedabad Center is working almost all the time, except for the initial lockdown. We have at least some people always working on the backside, doing various activities related to satellite communication, navigation, and other activities related to remote sensing. So till now we have 175 mission years we have completed, and these launchers, ESLV, GSLV, and various types of satellite, whether it is geostationary satellites or remote sensing, polar orbiting satellites. So all these are the workhorse of ISRO's space program. And our satellite communication and navigation will also be utilizing these launchers for Vikram Sarabhai, from where he started all this activity. And here this big antenna which you are seeing, it is a 14-meter antenna built by a Japanese company called Nippon Electric Company. Nowadays you know it by the name NEC. All of you must have heard this name. So this was the first antenna which was set up in this country, in our India. And this is the first building which has come up. It is called the Earth Station building. Because putting up a satellite is not the end of the story. Once we launch the satellite, afterwards you need this ground station to do the activities from space. So that's why the importance of ground segment is also very critical. I bring out those importance also. So this is the first Earth station which was built in our country. It is located in Ahmedabad. So right now we are not using this setup, but still we have kept it as a heritage building. So whenever you get a chance to visit Ahmedabad and Space Application Center, please do come and we'll show you this antenna. It is a 14-meter diameter antenna, and this is our main campus, which is almost 90 acres. It's a very big campus. And here now at the bottom you are seeing how we have expanded. So this was our initial campus in satellite area of Ahmedabad. And today we have another 3 campuses, as you can see here. This is the yellow one, this is the recently came up. It's called New Bhopal campus, and this is our old Bhopal campus. And then we have another education development and education communication unit which do social research also. Whatever activity we do related to satellite communication and navigation, whether they are reaching to the common man, what course corrections are required to be done, how we can modify it so that it benefits more for the people. So all these activities, research related to that, getting feedback from the users, from the common people, from the scientists, from the actual applications, all these things is being done by this unit. So they give us a very important feedback so that based upon that we modify our program in future. And then we have a very good exhibition center, Vikram Sarabhai Space Exhibition. Is worth visiting, and whatever I am going to show you today, all these details are available in this space exhibition. And now we have started in view of this pandemic, last almost 1.5 years, we are conducting various online exhibition shows or webinars or seminars also. So if your school is interested, please do approach us and we'll conduct a specific program for your school students also, or even teachers also. So that is the idea behind starting this online series also. And this right hand side you're seeing this building, again another big antenna, and this building is located in Delhi, New Delhi. It is almost nearer to our Honorable Prime Minister's office. So it is called Delhi Earth Station. Although it is located in Delhi, it belongs to our Ahmedabad center, and it has again a heritage value. Like this antenna also has a very big heritage. The heritage is that during the late 70s and early 80s, our Honorable Prime Minister used to go to this place and address the whole country, which was not possible. See, nowadays sitting at your home, you can address the whole country. Our Prime Minister sitting at his office or at his home, he can now address the whole country anytime. But that was not the case in 70s and 80s. So that time, this was the place where he or she used to come to this place. Mostly Indira Gandhi ji used to come to this place and address the whole country from this place. So that's why this place also has a very good heritage with it. Now we are starting a vendor complex, so it is like a very good corporate type of building here, where we will invite various private vendors who will come and do the work for ISRO. So this is in a nutshell is our campus. We do various activities related to payloads and applications. And why I'm showing this is that these are the activities. We not only make communication and navigation satellites, so payloads for that, because satellite is a common structure, as all of you would have known by now. So in this satellite, the heart of the satellite or the brain of the satellite is the payload which we put inside the satellite. So Ahmedabad or the Space Application Center is a place from where we build this payload or sensors. So they work like the heart or brain of the satellite, and they carry out the different applications. So once the satellite is launched, as I mentioned, using the ground station, we try to collect the data and then apply it for various applications. So today we'll be discussing communication, navigation, and its applications. How we build this payload and then its applications for various activities. And as you can see, this center has a unique value because it is a multidisciplinary center. Unlike our other centers of ISRO at Trivandrum or Bangalore or other places, the Ahmedabad center has a unique quality. The quality is what you can see, the manpower which is distributed across all the branches. You see, you find an electronics engineer also, a mechanical engineer also, a computer scientist also, and a geoscientist also, a science teacher like you also can, if he has a master's degree or PhD degree, he can come and join ISRO and work for geoscience or biological science or physical science or chemical science. So all these activities happen at our place here in Ahmedabad because we do a lot of application, as this title suggests. So a lot of application means we have agriculturist also, horticulturist also, and doing various biological, marine, oceanographic, meteorology, all type of applications, geological applications. So that will need people of different varieties or different skills. So that is the unique strength of this particular center, that we have hardcore technologists like me who have done his engineering in electronics or mechanical or computer engineering. But at the same time, we need scientists who will work on the actual application. So that's why this place is a unique place, because you interact with so many different varieties of people. So like in your school, you have maths teacher, you have science teacher, you have physics teacher, you have biology teacher. Something similar is the amalgamation that we have brought about in this my center here at Space Applications Center. Just briefly, Chandrayaan 2, all of you know, but why I bring this out? Because this Chandrayaan 2, last 1.5 years, it has been orbiting in space with very good results, and it also applies lot many communication and navigation technologies. Because data, once it is collected from moon, it is to be brought to the Earth. So then bringing it to Earth will need communication. So this is one major application of communication or satellite communication, that how so that beaming or the sending of the data goes through the communication link. So that is the importance of satellite communication. So to give you that example so that you can understand it better, that's why I have put this particular slide, that once our orbiter is moving around the moon, which is almost 384,000 kilometers away, but from there also I can bring the data to the Earth in no time. So that is the advantage of satellite communication. And same way navigation, how it is applied here is that this Chandrayaan 2 orbiter or the spacecraft is to be controlled in its different orbits. So it needs what we call the inertial navigation unit as well as a different type of navigation. So that's why navigation also comes into picture when even planetary missions like Chandrayaan or Mars missions are there. This is just to give you an example so that you understand better when we explain the nuances of satellite communication and navigation. Now, you know, this is Earth atmosphere, and beyond, all of you will be teaching your students about all these things, that we have this troposphere, ionosphere, and all different types of spheres. You know it better. And we work from, say, ground, that is height of 0 meter to almost 36,000 kilometers. And your atmosphere will go up to 40 to 60 kilometers. So beyond that, there is space, where there is vacuum, and there is weightlessness. So we work almost not only in space, but we also work on this Earth's atmosphere also. Because initially when we do experiment related to communication or navigation, we will try to use balloons also, we try to use aircraft also, we try to, satellite is the last stage when we launch anything at the height of 400 to 800 kilometers, or the final one, that is geostationary satellite, which will go up to 36,000 kilometers. And then planetary missions, which go up to, as I said, 384,000 kilometers. For a moon case or Mars case, it will be still farther. And then future we are planning flights to Saturn and Venus and all these other planets also. So that is called interplanetary missions. That is beyond that. But every all these activities will need communication as well as navigation. So that is the importance of communication and navigation. As I said, not only for our Earth missions, but the missions which we send to Mars or Moon or Venus or Saturn, and America and Russia have sent missions to Jupiter and Saturn and Uranus also. So they have been exploring space since many years, and now China and European Union also joined this race. And shortly, India will also be joining these interplanetary activities also. Where right now we have limited missions to Mars as well as Moon, but in future we'll be planning Venus mission also in near future, and that way we have our own interplanetary program. But as I said, everything will need communication. But as you go further and further from Earth, this communication becomes more and more complicated. So you need to apply different techniques to do this communication. These were the pioneers. I will not go into that. You people know it much better. All these laws, Kepler laws of motion, or when initially Galileo invented this space-related activities, Newton when he said that there is gravitational force. So all these things apply when we study satellite communication and navigation. And now we'll shift to satellite communication basics. Now all of you would have heard the name of Dr. Arthur C. Clarke. He was a British scientist or a fiction writer, and you can see the knowledge or the insight what he had about communication and especially satellite communication. That during those days, almost 100 years back, he was born. And in fact, all of you must be surprised to know, although he was a Britisher, his final almost 20-25 years he spent in Sri Lanka, which is our neighboring country. So he was there, he lived his life almost in his later life in Sri Lanka only. And in fact, in 2008, when he died, he was located in Colombo, Sri Lanka. So he is the great scientist or the great science fiction writer who gave this idea that if you have 3 satellites, you can communicate from any place to any place on this Earth. So that was his basic principle. And that means the 3 geostationary satellites, but that satellites have to be located at the height of 36,000 kilometers. Then only you will be able to communicate all across the world with the help of 3 satellites. So that means that if you have 1 satellite, you can cover 1/3 of the globe. So that is the basic principle on which this communication related to using satellites has evolved. And nowadays you have satellites in different orbits. It's called low Earth orbit, mid Earth orbit, and geostationary orbit. So, and there is something called planetary mission, heliosynchronous orbit also. So these are the various orbits of satellites. I'm not going into detail because we concentrate more on the satellite communication. But the basic principle is that if you have 3 geostationary satellites, you can communicate all across the world. So this is how the orbits of the satellite happen. So you have polar orbit, means from North Pole to South Pole or vice versa, the satellite will be moving. And since the Earth is moving beneath that, so it will, when satellite will go from north to south or south to north. But since Earth is moving, so this way you can cover the whole globe by doing remote sensing. So mostly our remote sensing or environment satellites are located in a polar orbit. They go from north to south, but mostly our communication satellites, they are located in this geostationary orbit. So as Dr. Clarke mentioned, if it is located on this equator at the height of 36,000 kilometers, then it appears steady. Why 36,000? Because it will appear steady with respect to Earth movement, because it is 0.5 kilometers per second at Earth's equator. So with similar speed, satellite is also moving. So it will appear stationary with respect to any point of the Earth. And then there are other category of satellites, especially our navigation satellite, which are located in the intermediate height of around 20,000 kilometers. Although Indian satellites we have put at 36,000, I will come to that, but these satellites are at 20,000 kilometers. So mostly GPS type of satellites, which we hear for navigation, they are located at the 20,000 kilometer orbit. So these are the different type of satellite: communication, navigation, remote sensing. But there are also camera satellites, which are called optical remote sensing satellite. Then radar satellites, which are micro remote sensing satellite. Weather satellites, which predict cyclones and gives you information about weather. Then the satellite which we send into Moon or Mars or such interplanetary missions. They are for interplanetary satellite or space science satellite for doing science studies. Then as far as the size of the satellite is concerned, there are nano, micro, medium or big satellites. So these are all the different categories. I will not dwell into much of that. But as you can see, and the future is what we are going ahead is a Gaganyaan module where there will be a crew module and an orbital module. And last but not the least, India also has planned to develop its own mini space station. So like you have Space Station Alpha, which has been made by USA and some of its partners, when India is not participating in the ISS space station, but India has its own plan of making its own space station. So this is how a satellite looks like. So as I said, satellite is a structure. It contains various electronics and various mechanical elements. So like south panel, north panel, east panel, west panel, like that, which will give you the basic resources for generating power, for sustaining its life, for doing communication, all those things. But the heart or the brain inside that is our payloads. And payloads are two types, communication and navigation, as far as these activities are concerned. So this is how the satellite. So these are the basic elements of any satellite, whether it is a communication satellite or navigation satellite, or it is a remote sensing satellite. So all these satellites or the satellite which are going to Moon or Mars, all will contain more or less similar type of resources like batteries. There is a bus structure, there are sensors which will give you the information about the location of the spacecraft. So all these things are common, whether you are launching a interplanetary satellite or a communication satellite or a navigation satellite. So command and data, pointing control, communication channels, thermal control, payload control, power supply for all these elements. So everything is common that is required for any satellite. And then the payload will be sitting inside this satellite, and that will do the basic work, the work of a brain or a heart, which will be the finally utilized for any specific application. So now coming to our satellite communication, this is how we started in 1975 when our Space Application Centers started working on various applications. So this was the first program. 2,400 remote rural villages were set up with the satellite instruction TV experiment. So you can imagine almost 46 years back, what was the condition of our country, India. And during those times, our team went to almost 2,400 villages all across the country and set up this TV station. So people can come and watch TV programs. So that was the basic idea. So that is one experiment on communication. So it was called the largest mass communication experiment ever carried out in world. We didn't have satellite at that time, 1975. So we hired an American satellite called ATA-6, and that paved the way for what we are seeing today, ISRO. This was the beginning of ISRO. And you are seeing the picture of one of the eminent, another scientist of ISRO, who also worked as a director of my center, Space Application Center, Professor Yashpa. All of you must have heard his name. He was a great science communicator and a great social research scientist. So any topic you give to him and he can explain it in such a beautiful and a simple way that everybody will understand the concept. So that is the niche, what we call the greatest hallmark of a great scientist. So that was Professor Yashpa. And he started this program in Ahmedabad, and it was located 2,400 villages all across the country. And similarly, since India wanted to develop its own satellite system, then this another experiment was done. It is called Satellite Telecommunication Experiment Project. So that is called STEP, and that was started after this site program was over. And that was a step in the direction that how India can build its own communication satellite system. So that was, and to build that system, first we have to understand how communication is being used for what application. So this program was more on application side. So it's called Satellite Telecommunication Experiment. So we used to do disaster warning system, radio networking, and transportable terminals were set up all across the country. And there was communication was happening from one place to another using satellite. So that was the precursor to this INSAT and GSAT satellite which we are building now. So this was understanding is how communication can be applied for application. So these two experiments were the major initiating steps for our communication program. And today you see you have this radio or TV broadcast direct to home. Nowadays you have your dish antenna at your home. Then you have meteorological forecast, as we saw it last week. Then two cyclones came and we are able to predict the track of the cyclone, where cyclone has reached, where there is going to be the rainfall or the landfall. So all these details, they are being tracked by our meteorological satellite, again located at 36,000 kilometers. Then we have our regular communication channels. Whenever you go to a bank ATM, you do some transaction, but the servers are located at a central place in say Bombay or Delhi. So although your ATM is situated in your village or a city, from there it communicates, your transaction details are communicated to the main server located in Bombay or Delhi, and from there it gives the go ahead, and then only you get your money from the ATM. So all this data, transactions, details, everything is stored in the central server, and that all happens at the backbone through satellite. You will not realize that, but that VSAT connectivity is for the ATM is through the satellites. And then similarly, we have all these national stock exchange where share business happens. So all these transactions also are controlled or communication happens through this our satellite system. So they serve as a backhaul of all these transactions. We will never realize. And nowadays, some people may argue that there is already fiber optic network everywhere in the country through our ground-based terrestrial network. So that is also being utilized. Although satellite still controls only 10% of the communication. Rest 90% happens through the terrestrial communication. So from that only you can estimate that there is a lot of scope for expansion as far as our capacity for communication is concerned. And apart from that, these communication satellites are also used for telemedicine, telehealth, and the importance of that we realize now during this pandemic. You're sitting at your home, you can consult a doctor through the internet link or a satellite communication link. So again, there satellite comes very handy. Then education, especially for your children, when you are sitting at your home or in your school, and you can teach your children or the students sitting at their home. So all these things you can do tele-education. So telemedicine and tele-education, importance of that we realized during this pandemic, that how it is right now we do it through internet also, but satellite also plays a major role in providing a backup structure for all this telemedicine and tele-education. And then that disaster time, all your communication link, telephone line, internet, everything gets stopped. If some of you would have experienced such a disaster when floods come or earthquake comes, so everything gets stopped. No terrestrial communication will happen. So that time our satellite system, INSAT and GSAT, they come handy because satellite are not getting affected by any earthquake or in floods or rains or anything. So they can work 24/7 anytime in space. So that's why the importance of satellite is because they work as a backup structure during this emergency situation. So this is how the application of satellite communication. So these are the different satellites which ISRO has launched all these years. I'm not going into the detail. All of you would have heard these terms every time. INSAT 1, INSAT 2 series, INSAT 3 series, INSAT 4 series. And nowadays we are developing our own GSAT series because we are launching it through our own launch vehicles, GSLV and PSL. That's why they are called now GSAT series. Earlier we used to go to French Guiana, Kourou. You must have heard this name, Kourou. Or we go to USA for launching our satellite, or to Russia. But instead of that, now we are self-dependent and up to 4,000 kg of class of satellites we are launching from our own soil because our launchers are capable of launching it from Sriharikota. So this is the summary of all the satellites which we have built, and they cater to various type of applications. And nowadays we have new type of satellites because as you would have seen, there is now a demand for different type of satellite channels, TV channels. Because any person who gets some money, he will start his own channel. So that's why the demand for TV channels is very high. And each TV channel will occupy around 3 to 5 megahertz of bandwidth. Now, if you see our previous satellite, INSAT 1, 2, 3, 4 series, the one transponder or one communication channel can accommodate 36 megahertz of bandwidth. So if I need 3 to 5 megahertz for one channel, that means I can accommodate only 10 to 12 channels in one satellite transponder. But there is almost, you see in your TV, almost 1,000 or almost 1,500 channels. So that you can calculate the bandwidth requirement for such channel, and all are giving data 24/7. So that's why the need or the bandwidth requirement has gone very high. Nowadays you hear this term spectrum demand or bandwidth demand or bandwidth on demand, spectrum usage, cost of spectrum. So all these terminologies come because bandwidth has become very costly. So each hertz or megahertz of bandwidth will cost you money. So to avoid all those things, we are now building what we call high throughput satellites. So satellite, instead of 36 megahertz, now they can give you bandwidth in same capacity or same resources. They will give you 200 or 250 megahertz of bandwidth. So almost 8 times higher. So I can accommodate, instead of now 10 to 12 channels, I can accommodate 100 channels in that particular area or the volume of the electronics which are put in a satellite. So that will make it more efficient. Now, as I said, putting satellite is not the end of the story. You need terminals also on ground. So you need a lot of ground segment equipments to use this satellite communication. So like that, we have set up our own communication station at even Antarctica. Now you can imagine, only 3 to 4 months you get in Antarctica for doing the work. Otherwise, almost 8-9 months, it is very cold there and almost dark. And how people will be working there and setting up the whole infrastructure, which you see here in our place in cities or villages here. So that similar earth station, what I was showing you at Ahmedabad, something similar was set up by our scientists. So you can imagine that how world has progressed now. You can go to Antarctica and within that 2-3 months you can build a earth station also, and which will start working and communicating with satellites. So I can collect data from this Antarctica and send it to India or USA or any place. So that is the beauty of this satellite communication. So as I said, to use satellite bandwidth, you need different type of terminals. So if you need a voice communication, you need say mobile voice, then mobile type of terminals, then you have distress dialer terminals, then you have a higher frequency terminals. So like that, it is not putting satellite is the end of the story. You need a lot of hardware or the electronics on ground also to meet these requirements. So this was one of the satellites which we built to support our neighboring countries also. It is called South Asia Satellite, GSAT-9. So now it is working since 2017. And it is serving all our neighboring countries. And as you can see, immediately after launch on 5th May 2017, that is almost 4 years back, our Prime Minister conducted a video conference, again through satellite, and offered this satellite for the use for all our neighboring countries, that is Afghanistan, Bangladesh, Nepal, Bhutan, all these people, Sri Lanka, and everybody is now using this satellite as a gift from India. Now, as I said, these are the high throughput satellite, how it will look like. So instead of that 36 megahertz bandwidth in a single transponder, now this will support almost 200 to 250 megahertz of bandwidth. So that will give you 8 to 10 times of channels. And this is our largest satellite which we have built till now. So almost 1.5 years back, we have launched this GSAT-11 high throughput satellite, which is one of the highest satellite ever built by ISRO. It is weighing almost 4,500 kg, and it has been launched because our launcher could not launch it from Sriharikota. So we have hired this Ariane space launcher from French Guiana, Kourou. It has been launched, and now it is covering the whole India. As you can see, all the regions, whether it is north, south, east, west, and northeast, all regions are covered by this new concept called high throughput satellites, and that will need almost 8 earth stations are built all across the country, 4 different corners of our country. So Ahmedabad, Delhi, Bangalore, and Ranchi. out the communication activity. So from any place to any place, all across the country, we utilize this GSAT-11 satellite to do communication. As I said, the communication happens in different beams. So, and this is another category of satellite, which is all of you know your mobile phones, smartphones. So this is something similar to your mobile smartphones, but using satellite technology. So whenever you have network connectivity, all of you know whenever you go from one place to another, many times you lose the network connectivity. And that is because the towers are not situated at that nearby place. So to avoid such situation, what happens is that wherever network connectivity through terrestrial link is not there, you utilize satellite communication because satellite is always present. So as we mentioned, 3 satellites if I put, it can cover the whole world. So something similar, you can utilize this concept to implement these mobile satellite services. So this is how a satellite phone will look like. It's slightly bigger than your smartphone, but whenever the communication through terrestrial mobile services is not possible, you switch over automatically to this mobile satellite services. So that is the concept on which people will be working now in future, that you have a seamless connectivity from terrestrial to satellite communication, and you will be able to operate your mobiles. And as I said, it is not only building space segment, but you need a big earth station if you want to support satellite communication. So this is how, say, nowadays for GSAT-11, what I showed you, the big satellite which we built recently, for its ground segment, we set up 8 stations and it costed us around 250 crores of rupees. So this all we are now trying to do indigenize this whole concept under the Atmanirbhar Bharat program. And shortly we will design our own antenna as well as all electronic system which you are seeing here. And that will be all done indigenously within India. So that is the aim with which, so it contains a lot of antenna, feed systems, transmitter, receivers, and digital systems as a part of this earth station. So as I said, it is space segment is one part of the story. Ground segment is again another part. Now we move to satellite communication very quickly. So what is satellite navigation? Sorry. Is how you try to locate a place in the world. Say, all of you know on a world map, you may be teaching your students how to locate a place on a map or on a world map or an encyclopedia. So here, say I want to locate this one institute, Tirupati Institute of Information Technology. It is located in Gujarat, Gandhinagar. So if I want to locate this place, how I locate? So I first try to find where it is located. It is in India. On the world map, it is in India. In India, it is in Gujarat. In Gujarat, it is located near Ahmedabad. Near Ahmedabad, it is located in Gandhinagar. So like that, we zero down to the exact place. When you zero down to the exact place, what you get is the location details of that particular. So latitude and longitude. So how to get this information? So that is the crux of the matter. Using satellite technology, how you try to find out location of any unknown place. So our India, it is in our mythology and all our other details, we claim that ancient India was the place where navigation has arisen. So Sanskrit word we all know Navagati, or in Sanskrit or in Hindi we call now. So Nauka. So this now, from that now, this navigation word has come. That is what our name is there. This is a typical depiction of that. But basically what we are trying to find is that, like I mentioned about the satellite communication, that 3 satellites can cover the whole world. Something similar happens here also. If you have 3 satellites, then I can find out the location of any place or any vehicle or any person wherever he is moving on the earth. So how 3? Because we have to find out P, V and T. It is called position, velocity and time. So now although 3 are sufficient, but 4th satellite is needed to improve the accuracy, and because we want to derive the timing information also. So that is the basic idea behind this navigation concept. So something similar to communication, but the concept here is that this satellite may be either located in a geosynchronous orbit, which is 36,000 kilometers, or it could be in if you want to cover the whole globe, if it is geosynchronous, then it can pointed out to a particular region. So that's why it's called regional services. And if it is on the mid-earth orbit location, that is what I mentioned, 20,000 kilometers height, then they can, since they will be moving always, because geosynchronous satellite will be always stationary, so they will look towards only one portion of the Earth. So that's why there is a limitation. But if it is in a MEO orbit or a LEO orbit, then since Earth is moving, they will cover the whole globe. But you need more number of satellites. So that is the trade-off between number of satellites needed and the navigation requirements of any particular country. So this is the basic concept, and India started its own program, and we have these two programs called Gagan, GPS aided. So here what we are doing is we are improving the accuracy of GPS satellites so that it can be utilized for navigation in the civilian aircrafts, because that was the idea of our Airport Authority of India. And then in 2016 we set up our own navigation with Indian constellation, NAVIC or IRNSS. Now this is the concept or principle of satellite navigation. There is a location, say in India. So it's coordinate X, Y, Z. So this coordinate I can find out using one satellite. Okay, so with respect to satellites, I can know the vector and I can know the distance and I can locate them. But if I want to zero down on that, I need another satellite, so that the intersection of that will give me another solution, because there are three variables. Any location, you need X, Y, Z, and T. So there are four variables, means I will need four equations. A basic mathematical formula, all of you maths teacher will know that for any variables we need to solve. So if you have two variables, you need two equations, then you will find out the solution. So same way we have now to locate any place on the Earth, you need four type of information, or four variables are there, X, Y, Z, and T. So you need these three satellites. And then as I said, because timing information is also very critical, so you need a fourth satellite. So that will also aid in improving the accuracy of our estimation. So that's why this is the concept of the intersection of these four satellite locations on the Earth will give you the exact location with a very required precision, accuracy, and along with the timing information. So that is the basic principle of navigation. So like communication, three satellites are bare minimum, but with four I can get the timing information. So as I said, initially GPS, all of you know, it is a very famous architecture, global positioning system. All of you know that. So it is in working since last 45 years. So, and it is being maintained by USA. So this GPS accuracy, if I want to utilize, say a plane moves from India to say USA. So during its journey from India to USA, almost 20 to 24 hours it will take. So if you want to track the path of this aircraft, so you have different type of sensors available. But if you have this Gagan system, so then you can get the exact location, the aircraft cockpit, the pilot will know its exact location with respect to the Earth. So that is the importance of this GPS-aided geo-augmented navigation Gagan system. So this system has been set up because normal GPS receiver, if I use in this aircraft, it will not give me the desired accuracy. And there are not many other error mechanisms are there that will distort the value of the location. So to avoid all these things, and then the other problem is that when aircraft moves from one place to another, it will pass through various countries. So it should seamlessly integrate and work with the satellites of that particular country also. So that's why this standardization has been carried out. So this is called satellite-based augmentation system. So this is again one form of navigation system. So we are augmenting GPS accuracies and its integrity in such a way that this can be utilized by pilots for doing landing and takeoff. Because normally you would have find that during winter seasons, especially in northern India, our planes are diverted. They are not in Delhi, say, or in Jammu, or in Srinagar, or in Shillong. So they are to be diverted, and they are either towards western side in Bombay or Ahmedabad, and then people are taken by road or by railways to their destination, especially during winter and when there is bad weather condition. So to avoid all something, because if the pilot tries to land in a bad weather condition, there is the chance of accidents. So to avoid all those things, now with this type of SPAS system, we'll be able to land even during bad weather condition. Of course, during extreme bad weather condition, it's not taking worth that risk. But during normal bad weather condition, still we'll be able to land in such difficult conditions also. So that is the advantage of using this satellite-based navigation system. Now coming to our own navigation with Indian constellation, we call it our Desi GPS, our Indian GPS, and it is our Honorable Prime Minister has given its name Navik because it has come from our Hindi or Sanskrit word Navik, now. So, and then we coined this acronym, Navigation with Indian Constellation, so which fits as a Hindi, Sanskrit or English acronym, it's Navik. So this is the Navik system where there are three elements of the Navik system. So you have space segment where you have 7 satellites, then you have a ground segment. So as I said, any satellite system, it will not work standalone with only satellites. It will need a ground system. So there are not many ground stations to be set up in the whole country. So that also we have set up. And the third part is the user segment. User segment means people like you. When you carry your mobile, in mobile you have a GPS chipset. Something similar you will have now Navik chipset in your mobile. So you can use Navik to find out your location. You are going to some new place, you try to locate a restaurant or a shopping mall or a multiplex. So all these things now Navik will help you to locate the new places. You try to find out the location, as I mentioned earlier. So we are now providing 2 types of services. One is for common user or a civilian like we people, and the other services, which is called a secret service or encrypted services, they are meant only for our soldiers. That is for our armed forces or strategic forces. So why this requires? We call it IRNSS. It was earlier called IRNSS, Indian Regional Navigation Satellite System. Why it was developed? Because during Kargil War, if some of you will remember, in 1999, our soldiers faced a lot of problems in Kargil. That they were using, because everywhere GPS is there. See, 95% of things which we utilize related to electronics, it will contain GPS chipset. So our weapons also contain GPS chipset. Our vehicles, which are used by Army or Navy or Air Force, they also contain that. Our fighter aircraft also contain GPS. Our naval carriers also contain GPS. So everywhere GPS is there. So what problem they faced was during that Kargil war, the GPS accuracy, they were finding it very poor. Instead of 5 to 10 meters, it was giving accuracies of 50 to 100 meters. So that will create a lot of problem. You fire a bomb, instead of landing up at the X place, it will land up in India itself. So that will not solve the problem, isn't it, during a war. So to avoid all such problems, Government of India decided that we should have our own system, because GPS is under control of US government or US Air Force. So to avoid all such scenario, we should have a system which is under control of Indian people or Indian government. So with that idea, this whole program of IRNSS or Navik was set up. It's conceived in 1999. Government set up a committee, and after that, the committee gave a report that we should have our own system. So we embarked on the system, and by 2006-07 we started the work, and within 10 years, 2016, we have launched all the 7 satellites as well as the ground segment. Everything was made ready, and now it is ready for launch for use by civilians as well as our strategic. So now in the world, you will have 1, 2, 3, 4, 5, and there is the 6th one from Japan also, QZSS is called. Although it is also a regional service like our Navy, and it is a limited services, so we are not included in this table. But if you see overall, there are these 5 major services which are available in the world, and India is one of them. So we have our own system, and as you can see, GPS is very famous. Last 45, 48 years it is working, and is under control of United States. GLONASS is from Russia. European Union, they have made a consortium, and it is called a Galileo system, and China has its own Beidou or Compass system. So we are competing with these 4 major players, and we have our own Navik system. Right now it is meant only for Indian regions, while all these other 4 systems, they are not only for their own country, but it applies. I can also use GPS here in India. Same way I can use GLONASS also in India, but NAVIC cannot be used by USA. So that is the difference between these four systems and our system. And the other difference is, as I was mentioning, these all systems, they are global system because they operate at the height of 20,000 kilometers. So that means satellites are always moving, while our satellites are at 36,000 kilometers. So they are look towards India. So that's why they are stationary. So it will to the needs of Indian region. So these are the logos of our logo is also equally beautiful as the other things. And services wise, as I mentioned, so it is covering whole Indian region as well as 1500 kilometers in and around India. So that is the aim of this navigation services of our Navy India. So it will cover from 30 degrees south to 50 degrees north and 40 degree to 140 degrees east longitude. And it will give 24/7 with a 99.9. Because any navigation service, once you declare it operational, it has to provide almost 100% services. You cannot say today my services won't be available. Then user will be in problem. So this is how this satellite which we built for navigation, IRNSS or NAVIC satellite, it is undergoing testing in our laboratories here at Ahmedabad as well as Bangalore. So this is just showing you a glimpse of that. And as I said, apart from satellites, we have also set up various earth stations all across the country. So they will aid in the improvement of performance of these satellite systems. So basically, anywhere you are located in India, you will be able to get exact location with the help of satellites as well as this ground segment. But you will not know. As a user, you will carry only the small chip, as you are saying. So initially, when we built the receivers, they were something very big like this because we wanted to test of these receivers of our system, of our navigation NAVIC system, that it is working perfectly at all the places in the country or not. Because it should not happen that it works in Ahmedabad but it doesn't work in Shillong, because then it is useless. So we have to test it thoroughly all across the country with all its features. So that's why you see different varieties of receivers which we have built. And finally, that receiver should come as one single chip. What is that chip? You can see in your watch or in your radio, you see a small tiny chip which comes from USA or Japan or Russia or America. But now we are building this chip in Chandigarh also. This is the chip which we have built in our Chandigarh complex. It is called at SCL, Chandigarh Semiconductor Laboratory we have in Chandigarh. And here I have showed you a block diagram, although many of you will not understand it. But what I am trying to convey is that I am an electronics engineer. I have studied for 4 years after schooling. Well, you teach students up to 12. Now after 12, we do engineering for 4 years. Now in this 4 years, whatever subject we study, starting with antenna to microprocessor or signal processor, everything which I study in these 4 years or 8 semesters, everything is applied in this, making this one small chip. So you can understand the complexity of any navigation system, that this one chip, small chip, it is costing only, if in bulk volumes, it will cost you only 10 cents. So you can imagine this cost is 7 to 10 rupees, the cost of this chip. But whatever I have studied during my whole 4 years of life in a college, in engineering college, in electronics engineering, everything is utilized to make this one chip. So from that itself, you can understand the complexity of any navigation system. And we have tested it all across the country, in east, west, south, north, all the parts of the country, and we try to measure the accuracy of our system, and we have found it. Although the specification was 20 meters, we have achieved up to 5 meters sort of accuracy. And to test all these things, we have to make antennas, we have to make receivers, we have to make chips or ASICs, we have to make simulators, and then we have made this timer display also, which gives you the timing like your normal clock timing. But the beauty of this clock timing is that it's derived from the satellite, and it will give you exact, accurate information. So always it will be rock steady. And as I was mentioning, the application of this navigation, as you can see, almost 98% of activity which you do in your daily life, everything uses GPS nowadays. So you can imagine the importance of navigation. So that's why India is developing its own NAVIC chips or NAVIC system that you use location-based services, road transportation, agriculture, aviation, timing. So all these activities which we do, surveying of your field, finding out the area of your building or your farm field, everything is being done with the use of GPS or differential GPS. So that is now will be done with our own NAVIC system. So you can imagine the cost involved and the market it is going to generate. Because as I said, almost 98% of activity you see here, everything uses GPS. So same way NAVIC. So now how we have used it for various applications, here you can see. We have Shatabdi and Rajdhani trains. So all these trains are now being tracked in real time using our NAVIC, that is a navigation satellite, as well as this is a communication satellite. So my location will be given by NAVIC satellite. So from the locomotive engine, it will go to this communication satellite, and from communication satellite it will go to this earth station in Delhi. It is located in Chanakyapuri. So you can track right now this our chips and our system are installing almost 2,800 Shatabdi and Rajdhani trains and mail and express train. And shortly another 6,000 trains will be equipped with this. So total we will have now 8,800 trains of our country, all will be equipped with this satellite terminal with a NAVIC receiver. So that will be tracked continuously. So you open your internet and try to get location where is this Rajdhani train which is going from Ahmedabad to Delhi. Right now where it is moving. So till now, what was happening was that when it passes a particular railway station, the station master used to pick up a phone and inform the Chanakyapuri central station that Rajdhani Express that passed Ahmedabad, or it has passed Baroda, or it has passed Godhra. Like that, they will inform to the central station, and then they will update the information on internet. And that way, you come to know about the location of the train. But that is the thing of the past. Nowadays, in real time, that information goes to Chanakyapuri Delhi station, and it will automatically get updated on internet. So this is the advantage of using satellite communication and navigation technology. Same way, unmanned level crossing, lot of accidents happen. All of you know that. So what will happen is that now when the train is moving and it is say 2 kilometers away from the unmanned level, this is the unmanned level crossing. So automatically this audio visual alarm will start ringing so that the people who are trying to cross the crossing, they will get stopped at that place. The person will hear this sound as well as see the visual indicator. He will not cross that particular crossing. So that is the advantage of automated unmanned level crossing system. So all the unmanned level crossing will be now equipped with these satellite-based terminals so that we can stop such accident. Similarly, lot many boats. All of you know what Bombay happened, that a boat from our neighboring country entered Bombay and nobody noticed it. Terrorists came out of that and fired at the innocent people, and almost 168 people died in that accident. So to avoid all such things, what will happen is that all Indian boats will carry this water terminal we are putting in this locomotive. So there are 4 lakh boats moving in various seas around India. So all will be equipped with this terminal. So their location in sea will be continuously monitored by our NAVIC satellite, and that information will go to a Navy hub in Gurgaon, and they will continuously track the movements of these ships. So any unknown ship if is coming, it will not be equipped with this terminal. So you will immediately come to know that there is some unidentified boat is moving around somewhere in our sea. So that will be caught, and our Coast Guard and other people, Navy, will take care of that particular boat. So this is the advantage of it. Then we have our fishermen going into the deep sea for fishing. So here you are saying, so we will give them a NAVIC receiver, so and they will carry a mobile phone, but that mobile phone generally is useless. It will work only on the coastal part. So when they carry that mobile phone, they will get all the information from the satellite in real time in their native language, whether it is Gujarati or Malayalam or Tamil. So the fishermen will get information about cyclones. So once they go into the sea, they will remain there for 5 to 10 days. So during that time, if cyclone is going to come, to alert them in time so that they can return back. Something similar where they will get better fish yield. So that information also we will give them every day, evening 5 o'clock. We give them this information. Then cyclone alerts, Then if they are crossing international waters, if they are going towards Sri Lanka or going towards Pakistan waters, they will be alerted that now you are violating international borders in sea. So all this information will be now be available through satellite, and in real time it will be available on their mobile phones, and that too in the native language. So that is all the advantage of using all this for the governance. Then we have somebody wrote to our honorable president, many of our soldiers die at Siachen. All of you know about Siachen glacier. The temperature of minus 55 to minus 60 degree, such a cold temperature, and we send our soldiers there for 3 to 6 month duty. One battalion goes, and after 3 to 6 months, they will return back, and another one goes. But many times snowstorms come, avalanche comes, and they get buried inside that. We are not able to even locate their bodies. We are not able to bring their bodies, dead bodies also. So that is a real misery, because a person is not, even we are not able to tell their family members what has happened to his body. So to avoid also scenario, somebody wrote to Prime Minister that India has now communication satellite, navigation satellite. So why not we use this technology to at least locate our soldiers whenever they move in Siachen glacier, because it is a remote place. So that's why we are trying to evolve one technology so that the soldier can wear it on his hand. It is like a wearable unit. So that wherever they are moving in Siachen glacier, that location will be known in Srinagar, because through satellite we get the location through our NAVIC satellite, and it will be communicated through our communication satellite, and that information will be continuously tracked in Srinagar also and in New Delhi also at the headquarters. So that is how we are planning the thing. The only problem here is that it is, as I said, very cold temperatures. So the battery has to last for 3 to 6 months, because there is no provision for charging the battery. Like you charge your mobile, I cannot charge the battery. That is one problem. Then the whole equipment has to work in minus 55, minus 60 degree temperature for almost 3 to 6 months. That is another challenge. Third challenge is it has to be very small in size, because soldier cannot carry my big electronic equipment. So that's why it has to be made like a watch, a wearable unit, which he can wear it on his hand, and he can be continuously tracked. So all these things we are trying to see. Similarly, there is something called pseudolight system that is also part of navigation system. So wherever aircraft in remote areas, say northeast or northern part in Jammu or Kashmir, where there is hilly terrains are there, if we want our fighter aircrafts or small planes to land, airports are not there. There is not a runway like you have in Ahmedabad or Delhi or Bombay. You cannot have big runways. So what you do is that you set up this small system called pseudolight navigation system, and that will use or aid in pilot in landing this small hilly terrain area also. So that is the technology as a part. So then similarly, all of you know Ola, Uber and all these things. So they operate on GPS. So now our aim is that how we can replace this GPS with our NAVIC satellite receivers. So we are making part of EIS 140. Government has evolved that standard, and all these Ola, Uber and all the vehicle tracking system will now be based on navigation system. Similarly, as I said, sometimes like you would have heard Chief Minister of, say, Arunachal Pradesh, he died in a helicopter crash. And similarly, Andhra Pradesh, Rajsekhar Reddy ji, also he died in a helicopter or a small airplane crash. And we were not able to even locate where the aircraft has crashed in the jungle and where the remains are located. So to avoid also scenario, now all aircrafts and helicopters will also be fitted with a satellite communication and navigation terminal. So this NAVIC and our mobile satellite service, they'll be utilized for tracking. So whenever helicopter takes off, from that time onwards, it will be continuously tracked, so that if some crash or any mishap happens, where it has happened, exactly we'll be able to come to know. Then similarly, in Naxal-born areas, our soldiers, all of you would have heard in Buxar or in Chhattisgarh and all these regions, ambush happens of CRPF patrol party, and many of our jawans died. to avoid also scenario to the next and again they will carry this terminal and they will be continuously tracked using our Navic and mobile satellite service. So when they go out in jungle, their movement, whether in vehicle or when they are moving on foot, they will be continuously tracked and sitting at a base camp outside the jungle or in Delhi or any headquarters also, they will know the movement of our troops so that any Naxalite ambush happens, we will be immediately able to rush help to the soldiers which are in distress. So this is how our various satellite technology will help in solving all such problems of government. So similarly, when we have our own launch vehicle program, so Sriharikota, from where we launch our satellites or rockets. So all these earth stations and timing stations all are also now synchronized with our